Hey, hi, hello guys, welcome back to Code with Nani channel. So today we're gonna discuss lead code problem of the day, which is minimum time to repair all the cars. So you are given integer array and ranks representing the ranks of a some mechanic. So on each rank of I is the rank of the ith mechanic. Okay, a mechanic with a rank R can repair n into r square minutes. So he can repair n cars in n into n r into n square minutes. Okay, cool. So you are also given integer cars representing the total number of cars waiting in the garage to be repaired, which means like they are given the s- cars C with the integer value, which means like we need to repair that number of cars which is waiting in the garage. And what is the total number of minutes taken by the earth mechanic to repair n cars is r into n square minutes. So we need to return the minimum time taken to repair all the cars. Okay, and all the mechanics can repair the car simultaneously. Okay, which means like they both all the people will work on a parallel way. Okay, that's cool. And they're given the integers. This is the car ranks, which is the ranks of each mechanic is 4, 2, 3, 1, and we have a number of cars as 10. Okay, the first mechanic, he will repair two cars. He'll repair two cars. So in order to repair those two cars, how much time he will take? So this is R. So the value of the R, the value of the rth mechanic. So 4R into n square. N is total number of cars that he will repair. So that will be the total minutes. 2 square, which is 2 square 4, 16. This is 16 minutes. And this 2 second mechanic also will take two cars, so which is 2 square. So this is 2 square 4, 4 to 8 minutes. And the third mechanic, he also took two cars, 3 into 2 square, 4 for 3 is 12 minutes. So totally how many cars until now we repaired? Two cars here, two cars here, two cars here. So 2, 2, 2, 4, 6. How many cars left? 4 cars left. So 1 into 4 square. 4 square 16. So 16 into 1, 16 minutes. So the total, so in order to repair all the cars, we require 16 minutes. So how this 16? So the first mechanic will repair his two cars by 16 minutes. And the second mechanic will repair 8 by 8 minutes, and he will be free on the remaining 8 minutes. And third mechanic will repair his two cars by 12 minutes, and will be free for the 4 minutes, right? The fourth mechanic will repair all his four cars in 16 minutes. So to club up all the things, the total time required for all 10 cars to be repaired is 16 minutes, right? So how do we solve this problem? How do we solve this problem? So if you carefully observe, we are using a binary search because, so if you watch my previous videos, so just by looking at the question you will get the intuition of this question. So why we are using a binary search? So if you want clear explanation of the binary search, do check out my previous video in this lead code play problem of the day playlist, where from the past 3 4 days we are doing the same binary search problem, so in the same template. So you never has to change anything, just we need to change some simple lines based on the use case of the problem. Okay, so long story short, just how we use binary searches. So in this problem, we need to return minimum minimum time, right? So suppose we have a 1 2 3 4 5 6 and so on k time. So if we can able to figure out a 6, which is a mid element, if using this we can able to with 6 minutes we can able to repair all the cars, then can't be done using 7 minutes? Even for 6 minutes we can able to finish the job, then 7 minutes definitely we can able to finish. We can just use that seventh minute as a leisure minute, and eighth minute Yes, we can do. So what we are doing is, if you go a statistical way, which means like if we can do it the sixth minute, but we need to return the minimum, right? So no point in checking seventh, eighth minute, because that gives you a maximum value. We need a minimum value, so we only check on the left side part of that. So that's what we do. So same intuition as your previous questions. Suppose if the mid is not possible, so if it is not possible, no point in checking the left side part of the array. Even we cannot finish the job by 6 minutes, no point in checking for the fourth minute, because definitely we cannot finish the job, so we only check on the right side part of the array. So that's the intuition of this problem. We can use binary search. So how do we use? I'll explain you now. What we do is, we'll just pass a mid to this. Suppose while left less than or equal to r, we'll find a mid element, which is l plus r by 2, and we check for a function if it is possible or not. If so, then we'll store it in the answer. If it is possible, what I told you, we will check for the left side part of the array. Else, if it is not possible, what we do, we'll increment l as a mid plus 1, so we only check on the right side part of the. So this is the binary search template. And then just return ans. Okay, that's cool. So how so how how do we check for a particular mid? So this is a boolean function, so which returns whether it is possible for that mid minutes. So mid can be any value, so we need to check whether for that mid, whether it is possible to repair all the cars or not. So I'll explain you how to use this logic. So we already given a cars. What is the example? 4231, right? 4231. So given array is 4231, and the total number of cars required to repair is cars equal to 10. So so this check function, so which is check function, will take mid as the input. So we need to figure out whether this particular minutes will be possible or not. So as you can see, what is the total minutes required for a particular mechanic to solve n cars is r into n square is equal to total minutes. Now, we have this minutes, which is the mid, right? So suppose the mid is, like for this example, take 16. So we know we need to figure it out whether 16 minutes is enough for all the mechanics to solve all the n cars, 10 cars or not. So we know the total minutes 16, and we know this is the r value for the first mechanic, and this is the r value of the second mechanic. We also know this r, so which is for the first mechanic. We also know this 4 into n square 16. So what is the n? The number of cars that he will repair in this 16 minutes, right? So n square is equal to 4, which is n equal to 2. So using this value, the mid is 16 minutes. In 16 minutes, the first mechanic can able to uh, repair 2 cars, right? We'll check for the second mechanic. Second mechanic, 2 into n square is equal to 16. 2 2's 8. 8 n is equal to, implies n equal to root 8, which is 4 root 2 root 2. So 2 into 1 point something, 2 into 1.4, 4 to say 2 ones 2, 2.8. Okay. And third guy, 3 into n square equal to 16, implies n square is equal to 16 by 3, around 5, implies n equal to root 5, which is basically 2 point some let's take 5, something like that. And fourth, 1 into n square equals 16, implies n is equal to 4. So if we add all the total number of cars first mechanic can able to repair, so in this case total number of cars until so far they repaired is first mechanic can able to repair 2 cars plus, and the second mechanic 2.8 something, and third mechanic 2.5 something, and fourth mechanic 4. So which is 2, 2, 4, 5, 6, 10, and it gives you around 11.3 something, right? So what is it is saying? So if you carefully observe, so if we work the second mechanic and third mechanic for the total 16 minutes, we are able to repair 11.3 cars, but we only require 10 cars to repair, right? So in this case the count is greater than or equal to k, which means we can able to repair. Now the count, this is, let's check this as a count and this is as a k. So the current count is greater than k, which means like if all the workers like work for 16 minutes, we can able to finish 11.3 cars. We only have a 10 cars, which means like the other two, these two guys can take some break, like this guy can work for 10 minutes and this can work for 12 minutes, so that they will finish two cars, this guy will finish two cars. Even that's the case, then we can able to repair 10 cars, right? So if the current count is greater than or k, which means they can able to repair k cars. So if they work for 16 minutes, they can repeat the 10 cars. In the same way, we'll check for all the mid elements. So what is the what is the minimum number of minutes, so that if all the guys work and with it in that particular minutes, whether we can able to repair all the cars or not. So in this case, 16 worked because the current count is greater than k, which means they can able to repair that k cars in 16 minutes. In the same way, if you check for 15 minutes, the same way we'll check for the 15 minutes. 15 minutes. So first guy, 4 into n square equal to 15, which is around 3. And second guy, 3 into n square. 3 into n square equal to 15, 5, root 5, which is 2.3 something. And third guy, 2 into n square. 2 into n square equal to 15, 14 something is 7.5, and if you root the 7.5, this is also 2.4 something, and 1 into n square, that is root 15. This is also around 3 point something. So if you add all the things, 6, now this is also 2 point some 1, and this is 2.2 something. So if you add all the things, 3, 5, 6, 7, 8, 9, this is 9.7, so which is less than the total cost. So what is the total cost we require to repair? Is total cost is 10 cars. We need 10 cars to be repaired on this specific x minutes, but using 15 minutes we only can able to repair 9.7 minutes, so which we cannot done all the cars to be repaired. So what is the minimum time required is 60 minutes, so we cannot able to do it in 15 minutes, so 16 minutes we can able to solve, so that will be the minimum value. So let's just run you through the code, you will get clarity around the question. So this is, so the same template we have been using for this binary search. So if you have any doubts regarding this template, do check it out my previous videos. So from past 3 videos, so for the binary search we are using the same, so same template. So you will get a question. So in the previous video I used to do int, but why we are using long, because even the question says we need to return the long, so that's why I'm putting everything on the long, or else we will might be out of the bounds for the integer values. And that too, in the previous videos we used to do 1e9, which is 10 power 9. Why we are using 1e18, 10 power 18? Because if you look at the constraints, the k value will be ranging from 10 power 6, as it is an r into n square, whereas r is the value of the rank of I. So if you carefully observe, so in each case we are doing r into n square. So constant for this r is 10 power 5. That is the maximum value. If you look carefully, look at the value of the n, which is 10 power 6 into 10 power 6. So if you some get the maximum value of this constant is 10 power 6 plus 6 plus 5, which is 10 power 17. So this is maximum constant value. So for that sake I'm just using 1e18, which is the maximum of the long, and answer is 0. While we iterate from less than or equal to r, we at each particular size of the array, we'll get a mid element, which is l plus r minus 1 by 2. We'll check for that particular mid, whether using that mid minutes, whether it is possible to get repair all the cars or not. If it is possible, we'll store it in ounce, and we will make that right as mid minus 1, because we need to get minimum value, right? So in the left side part of the array there might be a solution exists, or else we'll just make l as mid plus 1. We'll check for the right side part of the array if it is not possible to convert in, and in the end we return answer. So for the logic for the check function is check out. As I told you, this is a lambda function. So I already told you what's the use case of the lambda function. In order to get rid of the most number of parameters. So like if you write in a specific function, we need to pass nums and k, as it is as that function is out of the scope. As I'm writing inside of the function scope, I just only need to mention the k minutes, which is mid. Let's just take the count. Like we'll make a count, like with this specific mid minutes, how many cars that we can able to repair, and we'll compare whether that count is greater than or k. If it is greater than or equal to k, which means we can able to repair the k cars, right? So for auto nums in nums, we'll just return the count is equal to, as I told you, what is this. So I'll just explain you. As we are using r into n square is equal to mid, which is, this is the elements. So we are, in order to find n square is equal to, what is this? This is the nums of I for for a specific specific repair, right? Minutes of nums of I, and in order to get the number of course, we just need to square root it. So that's what we did, square root of mid by num, so which is basically nums of I. Okay, why we are using double? There might be a case where nums is greater than mid, so in order to get a floating point values as well, so there might be a case. So when 3 by 6, so as we did 3 by 6, if you only take care the int values, then definitely it will give you 0. Square root 0 will give some outbound value. So in order to get rid of it, we are getting the floating values, as 3 by 6 is 1 by 2, which stores by 0.5. So in order to store these floating values, we are using the double. Okay, floating values, we are using a double, and we'll get square root. Why we are multiplying with 1 ll means, as we are more concerned about the long, if you don't do it, so it may be, there might be a case where it will only give you the integer value. So in order to make it dynamic, I'm just multiplying with one long. Even you multiplied with anything with 1, still gives the same value, right? So for that case, I'm just multiplying with 1 ll, which is 1 into that value. So that one is long one. And finally we'll check whether it is count is greater than or equal to k or not. If it is greater, then it is possible to repair all the cars in that mid minutes. Okay, that's the solution. Let's just run the code and just submit it. Hola, it's submitted, and that is for today video, guys. So if you like my explanation, and if subscribe to my channel and hit that bell icon so you never miss any notification on my channel. And if you had any questions regarding my explanation or regarding any code, do put it in the comment section. I'll help you out, guys. And that's it for today video, guys. Thank you, tata, bye bye, see you tomorrow, bye bye.